So you discuss those things later. You agree, then you discuss those things later. No, now. So strict test, just go to the handout, then we pick from there. Last time we moved up to sample point, and then today we are picking up from the lower part of page 44, and we are starting from the ratio test. This is ratio test. So remember, we are trying to look at the convergence or divergence, and that's what we are targeting. So from the ratio test, I'm sure we know when we write something as good as this, we know what we are meaning. And then this one is a setting now, and we are saying if this is a setting, then we call it from this setting here. We can, if you want to test if convergence using ratio test, the video is not clear, the network is please, the network is stable now, I'm sure. So you see, this is remember when you look at this part here, it is the, please, those whose network is not clear, you can persist and move on with it. Reason being, I'm going to give you the video because it is recorded, so you'll be able to follow up. So look here, this part here.
Master, I think you zoom in because it's not clear.
There it is, okay? The problem is that some of you have stayed in the areas where network is not okay. So is it okay there?
Yeah, at least how.
Or if you don't want now, we can shift the lecture another time.
I know, sir.
It is also possible.
So continue.
Okay. So you see this thing here. Remember, we said when you pick up only this inner part, and we gave it a name, and we say this is the same as our sequence. And then when we combine it with the summation, then we say this is a series. Now, still I'm going to be strict, or I'm going to be saying the same, that when I say a sequence, you pick this inner part. When I say a series, I'm meaning the whole thing. And we said, remember, this one here, we said the same as writing from n is equal to 1 to infinity of this is n. And we said what is here should tally with what is there. So in the case this is k, so you move with k. This is k is equal to 1 to this is infinity of ak. And this is the thing. Now, you see, this is what I want to pick up from. And we are using ratio test. What we are saying, if that is the case, given this as the series, by ratio test, we can have the absolute value limit as this is because I've used the k, as the k goes to positive infinity, then of this is ak plus 1 over this is ak, then this thing here should go to L. Then we have to make now conclusions that if L is less than 1, this you should be keen with this. I think now this one you know it properly, because when I say k plus 1, what I'm meaning is that this is what you substitute in, that you substitute in any k plus 1. Here you substitute in k. You take the consecutive terms, 2 consecutive terms, you take the absolute value, meaning that this expression here, it is a must, should be either the lowest should be 0, because remember when you divide and take a magnitude, then it's like you have chased away the negative bit. Then you take the limit. And you remember, as you are taking the limits, the reason why I gave you chapter 4 is that most of these things have been covering them previously. You apply the L'Hopital's rule where need be, and then where you can manage to just do the normal things, then you move on. If L is less than 1, then we say that the cell, which cell? This cell here. Now you go back to the other cell, AK. We say that it converges absolutely. Converges absolutely. Absolutely, you put it there. Please don't remove it. If L is less than 1, you say the cell. Then you go back to the cell. Remember here, you have picked the sequences. Then here you say it is what? It converges absolutely. That is what you should do. See there. So also, too, if you have this is L greater than 1, the first one has been less than 1, then we say that the cell, the whole of this is AK, we say that it diverges. It diverges. Then 3, the moment our L equals to 1, then we fail to draw any conclusion about the cell. So we don't draw any what? Any conclusion about the what? About the cell. Okay. So you should be knowing what you are looking for. What is important, first of all, in this, please you should learn this, because where we are going, you may fail to know what we are doing. So we have by ratio test. What you have said, you have to go to the cell, you pick a sequence, you substitute the corresponding 2 terms, you take the most current divided by the previous. This is the most current divided by the previous. We expect this answer to be a certain value. So if that answer is a value, so we expect 3 things. 1, if L is less than 1, what happens? The sequence converges absolutely. But when we find that it is 1, we fail to make a conclusion. We don't say anything about it. When it is greater than that, you find that it is divergent. So I'm going to just strictly, I think, use the examples in the handout. So example number 1, we are having the first one, which is the sum. This is the k square. This is the 2 to k over this is the k factorial. And then this is the whole thing. It is under sum, the whole of it. So we have said you pick 1. We said you pick the sequence. So we can just take our AK be equals to k square 2 to power k. This is the over, this is the k factorial. That is the expression we are having. Then it implies that what? Since we are supposed to divide, it implies that also AK plus 1. It implies that where there is k, we are going to put k plus 1. That is the interpretation there. And then this is k plus 1. We square this guy. Then this is the 2 power k plus 1 over this is k plus 1, then factorial. So from here, these are the 2 things we are having. This can be called the equation 1. This can be called the equation 2. So we are going to use those 2 to divide them. And that's what we are targeting. So if we are to do that, then it is easy to do it because it's a matter of just dividing. The problem here, the challenge you are going to encounter as you are doing this work, it is to know how to substitute. The problem I find with some people here is how to substitute k plus 1. They fail to do it. That's why I had to start with the proof by induction to see the substitutions. So from there, we are taking now the limit. As this is k goes to infinity, of this is absolute of AK plus 1 over this is the AK. So this one here is equivalent to what? this is equal to, when we try to substitute, we are getting a limit as this is k goes to infinity of under the magnitude. We have the upper one, which is this guy here. Hope you can see it properly. So this is k plus 1 square. This is the 2 power k plus 1. Then under the same magnitude, remember this is over. I think I've done it in a poor way. I think I have to cross and repeat. Because I'm repeating the same thing, don't you worry. Because I want something bigger than that. I have this is the limit as k goes to infinity of this is the first one, and it is the ak k plus 1 square 2 power k plus 1, then over this is the over k plus 1. This is the factorial. We divide this guy with what? With the other k squared 2 power k over this is the k over this factorial. So this is the thing. Hope you can see it. That is the thing. I'm dividing, please. I'm dividing. Just divide them, no problem. Just divide them. Look at it critically before even I continue. Look at it critically. I'm just dividing them. So from here, I'm going to have this, and I want just you to remember one thing here, that if I have 1 over A, or A over B over M over N, I can easily write this as A over B, divide it with M over N, then after just say A over B times N over M. So what does it mean? Please, I thought the paper is balanced, but I never wanted to talk about it, but people are claiming that it's not balanced. Okay. So hope it is okay now. So this is the thing. This is the expression I've started with. So I'm trying to show you what I'm going to do. I'm going to skip this step, but we have, when you try to see, this is the level where I am of dividing. Now I'm going to just take the cross multiplication, then the lower part is going to interchange its denominator. So that is the thing I'm going to do, and expect that. You can try it. You can try it there on using your pen and to see what happens. So this thing here will equal therefore to, this is the limit as this is k goes to infinity of this is the k plus 1. This is squared 2 power k plus 1 over this is the k plus 1 factorial. Now you see times. You see this has been down, so it is going to go up, which is the k factorial over. Then this one which has been up, it is going to go down over this is the k squared. This is the 2 power k. So this is the thing remaining there. That's what I'm getting. It's what I've done. What I was telling you to do. And if I've finished that, I can easily continue with this same thing. I can still continue, but now we are going to cross out a few things here and there. I hope you know how to do with the factorial. So hope you know how to deal with the factorial. This is equivalent to what? So you see here, I'm going to be telling you what I'm doing. This is the same as the limit. As this is k goes to infinity. Look here now. What do we remain with here when we try to check properly? Can you see a factorial and a factorial somewhere? So I'm going to make some weird crossings here. So this one here, this is to 2 power k. This is to 2 power k plus 1, meaning that it can be written as k plus 1 squared times 2 power k times 2 power 1, then times k factorial. All over this is k plus 1. I'm going to rewrite something as good as this, that if I have k plus 1 factorial, I'm going to write it as k plus 1, then k factorial. Why? Because if I have 10 factorial, this is the same as 9. Sorry, 10 times 9 factorial, meaning that I want to see k factorial remaining. Why I want k factorial is that I want to cross this part here on the upper part. Because remember here I have it in my work, I have it here. So I want it to die with the expression. So this is k factorial. Hope you know now why I'm writing it that way. This is k square, then times this is 2 power k. So this is the expression when I try to simplify it a bit. So from here, what next? You will see that I can cross few things here and there. And you see a 2 remaining here, up, because I'm going to have this guy out and this guy out. I'm going to have this man out and this man out. You see here, you see this is to power 1. So I'm going to have this guy out and this man out. So what am I remaining with? I have limit as k goes to infinity of this is k plus 1. Then this one here remains times 2 power 1. Other things are covered. Then I have this is k squared here. I think that is the thing I'm remaining with. And then this one here will be limit. This is k goes to infinity of this is 2 into k plus 1 over this is k squared. Now, here we can, I think, separate the numerator, the upper part alone and the lower part alone. And this is limit as k goes to infinity. And because this is already positive, so we can forego the negative things. So this is 2k over k squared plus 2 over k squared. And because it is already positive, so we can just say this is limit as k goes to infinity of just 2 over k plus this is the limit as k goes to infinity of this is 2 over k squared. So mathematicians, what is the answer? I think this one here will be equal to this is equal to 0 plus 0, which is 0, and it's less than 1. So since the limit as k goes to infinity of ak plus 1 over ak is equal to 0 and less than 1, then sum ak equals to sum, what was the thing? K square 2 power k over k factorial is convergent. Is convergent. Remember, our interest has been how to show that this thing here is convergent, and we have already seen that our L now equals to 0 when you try to check out the so-called L, because we said the answer you get, we give it a name called L, and I think we are safe. Biaruhanga, you're asking something?
No.
Okay, I've been seeing your hand up. I thought you have an issue. So that is the thing there. I think we can look at something, some other example. So that example there, we're going to do it during a free time.
Help me explain the thing of convergence absolutely.
This one here is convergent absolute, actually. Convergent absolutely, sorry. Now you see, you based on the expression given to us, they have told you that when you take the ratio of the sequences, they have said when you have ratio of the sequences, if you are given a cell, some AK, you pick you take a limit as maybe K goes to infinity, of this is AK plus 1 over this is AK by magnitude, you'll get a certain answer called L. Now, we base on this answer to make a conclusions. If L is equal to 1, we don't have anything to say. We cannot say it. If the answer L is less than 1, if the answer L is less than 1, this one here converges absolutely. And we have said if the answer is greater than 1, if the answer L is greater than 1, then we say that it diverges. So those are the things I want you base on that theory behind it to make a conclusion, is nothing else. So that's the only thing. It is cheap, don't worry, it is cheap. It is something easy. So let's look at number. No, it cannot diverge absolutely. It diverges, and we say diverges in most cases it will go to what? To infinity. So it will diverge absolutely or converge absolutely. Sorry, it will diverge or converge absolutely. So you cannot say it whatever. Now let's try to look at some other examples using.
Excuse me, sir.
Yes.
My question is, like, when they are to bring a number, do they always tell you to use the P-series test, or they tell you to use, like, they specify the test?
Because in most cases you have limited time, they will be specifying that using this. But sometimes where something is only can be applicable to some type, they cannot. But for simplicity, and you have limited time, someone can say using this, show this, or using any appropriate. Because remember, what you are going to do, it carries marks. So meaning it's better someone to identify for you the method. But don't, you are making a rule. We said don't get worried about how questions are set. Concentrate on understanding. Because this is just a beginning math. Those of you who are going to go for masters, then you see that you don't have a path out without this math. So please.
If the limit was infinity, how do you conclude? If it was positive infinity or negative infinity, is it inconclusive, or we use another method?
You see, don't take me back, but you see this thing here, we have said L equals to 1. This one we don't conclude, right? L greater than 1. I think infinity is greater than 1, right?
Yes.
Then it diverges, human. L less than 1, then this one, always they will know. It converges absolutely. This is the only thing you should be knowing. If you know that this one is greater than, this one is less than, that's the only thing you should be knowing. But remember, your answer cannot be negative because we take magnitudes. So that is the little you should be knowing. Yeah, I know you are bright students, so. Let's look at, please, you are going to recap with the other example. Let me give you some work here. Let me calculate for you more numbers here. So this is the thing, using ratio please you can write using ratio test. Determine, using ratio test, determine the convergence of the following. We have number one. Please concentrate on understanding. Don't write unnecessary comments. You get confused. This is the 2 power n over this is this. Number 2. Number 3. So we are going to determine whether these things are convergent or divergent, but we are going to use the method we have seen already, which is the ratio test. So, hope you have finished copying.
Excuse me, sir.
Please.
Excuse me, sir.
Yes, please.
So number 2, is that one's n squared or cubed?
Any cubed.
Fine.
Okay. Please, I will try to upload the work. I don't know. I may get time to record for you the videos of the chapter 4, but if I don't get, please, you read on your own. They are simple things. Those are simple things. I have. Is it Abinitwe? Is it? Please, you unmute and you ask a question if you have. So number 1, let's move on to number 1. This is the sum, n is equal to 1. This is the infinity, 2 power n over n factorial. So using limit, n goes to infinity. But now you see here, look here, please. You see, when you are given the expression in terms of n, you are free to limit your expression in terms of k. You change it, you change the variable. You assume that you are going to pick a certain value called n, like the way you are going to see under integration, convergence in math, in pure math, that you are free. Actually, it is the best. You pick now, you change the variable of this from n to k. When you have given you k, you change it from k to n. Why? Because we assume that you have moved from n, but you have gone up to certain value called k. So that is the thing I wanted you to know there. So we are going to have this is ak. This is k plus 1 over this is ak. Someone is asking if it can be given in terms of trig. Yes, it can. So the problem is one, it can be scarce, but it can be asked. Please, I'm going to substitute at once. This is k goes to infinity. So we are substituting k plus 1, meaning that we are going to go to this, we add k plus 1. So this is the 2 power k plus 1 over this is the k plus 1. This is the factorial. Then we divide this guy with the same expression, which is 2 power n over n factorial. So over k factorial, this is k, sorry. And since we said with the division, you are free to use the other division or to use this ordinary division, we know. Then this is equivalent to ln k goes to infinity. Then we said you cross multiply. Then this is funny. So I know there are good people here. you can simplify this. You cross this and this, we get a 2 there. This and this, we get over this is k plus 1. Okay, let me do it. Those people here, I know people fear numbers here. Please, this is something easy. I know it is new to you, but I know you are not used to dealing with the these factorial things. But now I'm assuring you, it is easy thing. After the lecture, you will look around, then you see that thing that is easy. So I've crossed something there. But you have these things in your handout, so it is not a big deal. So you see this is 2, then over k plus 1. I think other things have gone. So taking a limit, we get 0. And since limit as k goes to infinity of ak plus 1 over ak is less than equals to 0, less than 1, then the set, this is the set. Someone is asking me a question. Converges absolutely. Someone is asking. Then I'm going to do number 2, you do number 3, because number 2, there is some result I want you to see. Then you see how it works. So, hope you have seen what you have done. Let's go to number 2. This one is putting on a video. N is equal to 1. This is 3 power n over n to 3. So, using limit as n goes to infinity, ak plus 1, sorry, an, so this is equal to what? Is this thing here, no one can penalize you because of not changing. Eh? That's why here I put n, then here I put k, but I'm changing it backwards. So no one can penalize you because you have not changed it. But what you should know, it is better. But if you have not changed, it is okay. So this is when I increase by 1, I divide this. This is the limit. So please make sure that you know what you are doing. So Mogoni, yes? This is Mogoni, can you tell your friend can you tell your friend Mogoni to do something? So this is so this is I think now you know what I've done. I've cross multiplied. I've cross multiplied this guy here. I've cross multiplied. because this has been division. So I'm trying to dodge time. So this will remain. Now, what is the limit here? So I think a 3 can move out because it's already positive. So these have said changing the n, it is okay if you have not changed, and it's okay if you have changed, but it is better when you have changed. So you will see that some reference books I gave you at the beginning, they will change. Others, they will not change. So changing, it's okay. And the change also, failure to change doesn't, someone cannot penalize you because of not changing. It's also okay. So don't get over challenged over that. So mathematicians, what is the answer here?
I got 3.
You got a 3.
Yeah, it's a theory.
Yes, it is 3.
It's divergent.
Please, those of you who cannot manage to get it, please you can consult your friends. But it is that. This is simple analysis. Since what? Since what? This is AK or n plus 1 by magnitude limit n goes to infinity is equal to 3 and it is greater than 1, then we conclude that this study here this is 3 to n. This is divergent. Now you see, this is a 3, but it's already greater than 1. So we can just take it easy and say it diverges. This, those of you who are interested in number 1, please, I think you'll watch the video, then you'll be able to identify it. I'll send it to YouTube. Please, can I leave number 3 for you?
Yeah.
Okay, good.
Number 3, is it, excuse me, sir.
Yes.
Number 3, is it n squared plus 1, or what is it,
Yes.
the denominator?
Yes, my dear, it is.
Numerator.
It is the denominator. You're asking for the denominator.
Yeah.
Someone is asking, how did I get a 3?
Can't it be n cubed
My dear, it's like this.
instead of?
Someone help me. On which page are we?
We are still on page, at the bottom of page 44.
Okay, thank you.
Please, how to get a 3 here? How can someone direct us how to get a 3 here? Because someone is asking that.
So like that's the same as 3 limit n tends to infinity, then n cubed out of n plus 1 cubed. When you substitute in the infinity, the other side, you get a.
You go to Rehopitals, right?
Yeah.
You go to Rehopitals, right? Because this is the 3, limit n goes to infinity of this is 3 over this is n plus 1 to 3. When you substitute here infinity, it will be infinity over infinity, so it will be imbalanced. So you differentiate. Limit as n goes to infinity, this is 3n squared over this is 3 into n plus 1 squared. You repeat this, you will find that it will keep reducing until when you get a 1. Actually, you get this is what? 1 over something, then this one now will go to 1, then here will remain with a 3. But please go to the hospital, revisit the hospital. Now, those ones who are going to look at number 3, number 3, the answer you are going to get is equal to 1. The answer will be 1. And then you say that you have failed to conclude. The answer for number 3 is 1. You want me to repeat this? Can we do it or we will do it?
We do
So
it.
for me, get 0.
You have got 0?
Yes.
Okay, let's try
Yeah,
it.
first you do it.
Okay, let's move with it. My students, you are good, right? So this is the thing here. Now we are going to just take this is the limit as n goes to infinity. This is we substitute at once. 1 over this is n plus 1 square plus 1 divided by 1 over square 1. And then when we take when we try to simplify, 1 over n plus 1 square plus 1 times over this is 1. This is limit n goes to infinity. Now this is a thing. You are lucky that here nothing is dying. So it has come back. It has come back. It has come back for the other thing of yours. So the first time we differentiate, we are going now. This is the hospitals. That is the first thing when we differentiate. So still this 2 will go with this 2. When you put still by hospital, it will get the same answer. So we go back, we differentiate again. We get 1 up, also we get 1 there. This is equal to 1.
Excuse me.
Yes.
So when I reach that part of n squared plus 1 and I open brackets, can't I just divide the top and bottom by n squared?
It is still getting you the same thing. You want me to check? That's what you used?
Yes, and I got
over n squared plus 2n plus 2. When you expand it, it will be this. So you're doing every time you expand it normally, but it is like that. So from there, let's try to divide and we see what we get. It is the same thing. So what does it mean? This is 1 plus 1 over n squared over 1 plus 2 over n plus 2 over n squared. When I divide, this is 1 over 1, which is 1. During every time you get a 1 when you cross the thing. So it is 1. So you make a conclusion that we fail to conclude. So we cannot determine whether it is, actually, we just say by ratio test, we fail to conclude, or we fail to make a conclusion about the cell. We cannot determine whether it diverges or converges, but what we are sure of, that we don't know. So if we don't know, then we give it time. We give it time. So because we are going to use alternating okay, someone is saying I should reduce speed, but my speed is not too much. So you see page root test, please. I said you read about it. Root test, you read about it because I'm not going to use it here, and it is similar to that one of ratio test. So even some texts, what they do, they put them together. So what you should know is like that. So let's go to alternating test because there is something as easy as it is there. Because also we are going to use it somewhere in the other last two. So look what that alternating test. Go to the bottom of page 45. Go at the end of page 45, please. You look at that first statement. I'm giving you just 1 minute. Please first go there and see.
So as you give us that 1 minute, can I have a look at the questions that you gave us to do?
For when? Now?
Yeah, the previous questions, because I joined late.
I didn't give you questions to do. So what I did, we have been calculating numbers. And then you need to visit the video after. And some people, okay, let me display number 3. Those the person who have just come late. I think for you are going to follow up in the next concept, because this just right. This is question number 3. We are determining whether it is divergent or convergent using ratio test, and this is the working there. So hope other people have finished. So let's go to alternating test. Please, let's go to alternating test, everyone.
Nabufu, hi.
So let's move on now. Given a cell, and remember, we have said still a cell is written as this. And we have said this is the cell which is having 2 components. We have said we have one, the first part is the sequence, which we know. Then when you add those things, then we get back to a cell. So this is a cell. You pick your sequence AK, this inner part, and this expression ever, if this method is to be used, ever to be looking like this. Then this is big K. So we know K. This is K coming from where? N. This is ever the expression. So if you are given N, any cell, you extract the sequence, you write it in terms of this. Then take what? Take a limit. Take a limit as this is K goes to infinity of this subsequence. So you see this part here, you are given a cell. From that cell, you pick a sequence. You know how to pick a sequence. Then you write it in terms of this format here. You write it in terms of this format, ever. This is +1. Then after writing it like this, you make sure that the BK is separate. Then you pick BK, you take its limit. If it goes to 0, then you go back and conclude that the sequence the cell I started with converges. Is there any question, please? Is there any question if you feel like you need to ask there? We have said you are given a cell, you pick a sequence, you rewrite it as this form. From here, you pick this, you take its limit. When it goes to 0, you conclude that it converges. Otherwise, it doesn't converge, meaning that this one specifically must be a 0. If it is not a 0, then you say it diverges. Then, an addition to this, you'll find that most of these should be a decreasing sequence, and it should be positive. So also, I think you add it there. Should be decreasing and positive, BK. The one you pick, decreasing, then positive. So that one is a must. Should be decreasing, should be positive. So make sure that you identify those things, those characters, before even you move on with it. And then you don't just see them, but you have to make a conclusion about them. We know how to show that it is a decreasing one. We know how to show that it is a positive. Positive if there is no negative value there. So this is the expression, and if you have got this, you are great. I'm sure there is nothing like a question in there, but let's see examples there. I think I give you this one as the exercise, and yeah, that one on page 45. Those are two numbers, they are exercises. I'm going to send you a link today, and you do them. I'm going to send you a link today, and you do them. So let's look at some examples. I've first given you exercise, then let me give you some examples here. When we have sum, -1, n plus 1 over this is n to 3. This is a 3, please. That is number 1. Number 2. Let me see if I can have some more examples here. We can have this number 2 here. Number 3 here. Because people said they want a let me give you a hard one because this is sin n, number 2, number 4. I'm going to, please, I'm changing the arrangement. This is number 1, number 2, number 3, number 4. Please change those arrangements. That is the working, that is the idea we're going to follow. Number 1, number 2, number 3, number 4. I've rearranged them because of some complications we are going to find out the counter. So number 1, this is the -1, n plus 1, cube root n, cube root n. So we said you pick a sequence. This is n equals to, you pick. You see this one here is the same as -1 to power n plus 1 all over n to 3. This can be written as -1 to power n plus 1. So you see, this is something good. This is something funny. What I'm trying to capture, this guy here to be outside. I'm repacking this expression. I'm repacking it. So this is the thing. I pick up also that. So times, this is 1 over, this is 3, this is n. And this is the same as -1, n plus 1, 1 over n to 1 over 3. This is equal to -1, n plus 1, bk, where bk equals to 1 over n to 1 over 3. So this is the thing. Yes. So let's limit as n goes to infinity of this is bk equals to what? Equals to limit as n goes to infinity of 1 over n to 1 over 3. What is the answer? This is a sequence. What is the answer? This is a sequence. I think, remember, we said when you take if this is a sequence, we are determining convergence of a sequence. What is the answer?
It will be divergent because the power is less than 1 if we are to use the P-series test.
No, this is not a series, this is a sequence. You see, now you have a lot of information in your head, so it is nice. You remember the other time we are sketching something that, and when we are substituting, we said when it is 1, it will be a 1. Actually, if I have an interval 0, then I have it will be a 1. You see that these values, when you go on substituting, they will come back here. There will be many here. And this guy here, therefore, will be n goes to infinity, bk equals to 0. Because you see that convergence will be done around at this point. It will not reach 0, but it will be close there. Because when you say 1 over 1 million to power a third, it will be 0.00 something, but it will not be 0. This is a series, not a sequence. This is a sequence and not a series. So you should be knowing when we say you pick up a sequence, you should run back to the theorems and the applications of sequences, not the series. Anyway, if this was a series and we are using p-test, if it was like this, 1 over n to a third, then you would have been right because this guy is less than. For p series it will be right if this was a series, but it's not a series, it is a sequence. That's why I've been specific that this is a sequence. So, and then we are going to say since limit as the n goes to infinity, this is bk equals to 0, then the sequence of this of ak equals, this is the series. This is -1, n plus 1 over under the square root 3n. That is the thing. Converges. Because we have seen that this guy goes to 0. How can you differentiate a sequence from a series? Even I. We said a sequence, what we called a sequence, we don't add, do not add. Meaning that if I write as my sequence ak equals 1 over n, this is a sequence. But if I write something like ak equals to, this is the sum 1 over n, now this one is a series. A series, we said you add. A sequence, you just list the terms. And then we said this one you can write even in terms of this to mean you are going to list terms or elements. So please, you must read those things. So let's go to number 2. This is number 2 here, the last one. Now still have made me fail to complete, but we shall, I think, see next time because I'm seeing almost 1.5 hours. This is number 2 here. Then this is now this is 1. Please look at this thing here. So let's move on now. You see the thing here. Let ak equals, this is -1 to power n over this is this guy. Please look here. Okay, I'm going to just do it because I wanted to show you from the previous work. This one equals to, this is -1 power n plus 1. Why am I introducing plus 1? Because it was there initially. So someone is asking something. Can you ask, please?
what happens in case you have n minus 1?
Yeah, I wanted to dodge that expression, but now you are forcing me to go and work out your number. Okay. Okay, let's put minus 1 here. Let's put minus 1 there. Please change the question a little bit, because there is something I want you to know now. But you have tricked me. Okay. Okay, this is the thing. This is the thing. Now, this will be negative 1 to power n plus 1. This is a negative 1 to power 2. Negative. So what I've done, I want to be able to add back these powers so that when I add n plus 1 minus 2, these powers, I get back to n minus 1. So you have to generate possible ways of maintaining this guy available, irrespective of the power given. And also you must make sure that this one is negative 1, irrespective of anything given. Hope I'm tracking you well. So I've said you make sure that this one is maintained, but you can change anything around. So that's what I'm trying to track. So this equals to what? This equals to negative 1 to power n plus 1. Then this is a 1 over negative 1. Yes, please.
Do you mind
yes,
repeating this expression from this part where you were explaining the n plus 1 minus 2?
I've said the question, which is number 2, is like this: sum negative 1 n minus 1 over this is 3n, and we have said you pick, let ak equals to what? Negative 1 to power n minus 1 all over under the cube root. This is n, and we have said that you must make sure that you rewrite your expression in terms of, it is here. You see this guy is maintaining negative 1, but k plus 1. This expression should not be tampered with. Ever should be there. So your work is to generate bk, but maintaining this guy. And then, when you look at ours now, this expression is not plus, but it is minus. So what we do, we look at the possible ways of putting this same expression, but with a plus, without changing the meaning of the expression. And this one will be this guy, n plus 1. Now, since I've put plus, then I have to make sure, or else you can just have this is n minus 1, then plus 2. Oh, this is funny. This is negative 1, n plus 1, then minus 2. That when you simplify this same expression here, when you try to analyze it, it is the same as n minus 1. Then all over this is the n to power third. Now this one here, because I'm interested in this, I'm going to have n minus 1 to power n plus 1 times this is now negative 1 to power negative 2 all over then n to power third. Now I'm going to pick up this guy here as my b, but after analyzing what this negative 1 will look like. This is negative 1. So you will see that this same guy will be the same as negative 1 to power this is n plus 1. Then when I multiply here, this will be the same as 1 over 1 to power 2. Because this is the negative power, so when it goes down, it will be positive now, but it will be negative 1 there over n to power a third. But now any number to power 2 is positive, so meaning that this negative will disappear and it will not affect this guy. And the final, I'm going to have something as good as this. I'm going to have something equals to, this is negative 1, n plus 1, then all over n to power a third. Now remember, this is the same as writing negative 1 plus 1 times bk, where my bk equals to
Sir,
1
please,
over
let me
n.
see the upper page.
You students, what is the problem, Bandai? Have you seen it now? Please,
Yes, sir.
everyone struggle and please, everyone struggle and reach this point. If you cannot reach there, you ask a question. Everyone struggle and reach there. If you have finished, if you have reached there, then you tell me and I move on.
Yes, we have reached there.
Okay, let's move on now. So when you try to check out now, please, can you get me the answer? Remember we said after getting D, you take a limit. Take a limit as n goes, as k goes to infinity of bk. What do we get? Please, can you try to look around? This is the, oh, we have taken k, this is n, b, n, this is n, this is n here, this is n. So can you see a 0 somewhere?
Yes.
Okay, that's nice. So now, let's go to the next. Let's go to the next question. I hope I can see it here. Let's go to this guy. Hope you can see this one here. Now, the right way of doing it is simple. Let's try to see with every condition included now, and then we conclude the work. Now, let's try to see number 3. After number 4, then I think for today we shall stop. This is something funny. This is this is negative 1, n plus 1, 1 over n. So when we solve this, let our AK equals, this is negative 1, n plus 1 times 1 over n. This implies that BK will equal to 1 over n. Since BK is positive, and decreasing as n goes to infinity. So I think when I say decreasing as n goes to infinity, you have to show that indeed is decreasing. You know how to show. Remember we said, how do you show that it is decreasing? You show that whether it is increasing or decreasing by using BK. If BK is less than BK plus 1, this is the work we covered. You use this thing here, or BK plus 1 is less than BK. This is increasing, this is decreasing. This is what you should show. Meaning that if they tell you to show by this test, then you don't say it is decreasing. No, you have to show that it is decreasing. You can only show that it is positive by just looking at it, because looking at it, no value of n. If my n comes from n, no value of n can be produced and this answer be negative. So it can be seen that it is positive. But you cannot see that it's decreasing or increasing minus testing. This is here is now a sequence. So use the knowledge of sequence, how to test it for decreasing. So if someone is saying it is positive, that one we can see. But decreasing, you cannot see. But here I have not been showing them because I wanted you to see something different. Also here, BK is positive, everyone can see. But you cannot see that it is decreasing until when you have tested. So you have to test for decreasing. We have been skipping something here because the theorem is telling us should be positive, should be decreasing, then the limit should go to 0. All those conditions must be satisfied. So when you are given a question and then you see a lot of max 10, 20, 15, and then you just do part of it, then you not get max. So please, you must be knowing the theorems, especially where I've taught. They should be at the fingertip. So that is the expression there. That's what I may request. So here you are going to show that it is positive. Already we can see. Decreasing, you are supposed to show it. Show it. You are supposed to use this idea here. Then 3, you are supposed to show that limit as n goes to infinity of this is bk, that the answer is 0. Then to conclude that it is convergent, automatically this answer is 0. When you try to take a limit of 1 over n, the answer will be 0. So I'm requesting you, do whatever. So, and then you should know, I will teach you, I think, what we call absolute convergence and divergence. Because this one here, we proved somewhere that these are halves, and then it was divergent somewhere. I will show you why when you combine it with a negative one, then it converges. But when it is not, then it diverges. So I will show you this expression because remember 1 over n, we proved it and it was divergent because it was 1 over, or it was a half plus a half plus a half. And we also proved using other tests and it was convergent. But when you combine it with this, it converges. So I will try to show you what happens and what is the procedure there. So let's look at this one here with a lot of analysis so that we can try to know what to do. Otherwise, it is not easy. So this is a negative 1, n plus 1. Magnitude is sine n over this is n square. And this one here, we are going to pick. Let ak equals to negative 1, n plus 1, sine n square. This implies that our big
number 3.
What is missing, my dear? You see, this one you are supposed to show this answer will converge because when you take a limit, you want me to calculate this one, but I'm not going to calculate it because this one here, calculating BK, you see this BK, you go back to series, you will see we are calculating it and every time it was convergent to 0. That's what I was drawing it. That's why I was doing it here. Because I was showing you that when you put 1 from 1 over n, the first one will be 1. These values will keep decreasing, but it will camouflage within there. So you find that it will, when you take the limit of 1 over n, it will be 0. But I was summarizing for you what you should present in case it is a question. That 1, you have to look for Bn. You must confirm that it is positive. We have seen that one can be seen by the eyes. You must show that it is decreasing, and you know how to show that it's decreasing. You must take a limit and show that it is 0. then this one, when you take it, is 0. So it converges. So there are three things you are supposed to look for: being positive, being decreasing, being convergent to 0. Then you conclude that where you picked it from, it is truly a convergent expression.
Excuse me, sir.
Yes,
me.
Oga. Yes.
Sir, now if I get the limit as n tends to infinity of bk and the answer is not 0, let's say it's infinity, do I conclude
No, it is
that
divergent. Even if the answer is 10, even if the answer is 10 but not 0, you say it is divergent, because I talked about it at the beginning. Yeah.
Okay.
If it is not 0, it will be divergent. But if it is 0, it is convergent. But you have to confirm all the three characteristics. Now, there is a problem in this number here you are seeing me doing. That's why I'm doing it, so that you can see how things can fall apart. So this is the sine n over this is the n squared. Then, so this, let me even write it in the way you are used it to. This is a sequence. So, 1, Bn, the sequence Bn or Bk is positive. That one, I think everyone can see it. Is there anything you may ask? We are supposed to satisfy the three characteristics. I want to see you to see where it may fail. Then you diverge from the answer we are used it to. 1, the sequence is Bk is positive. Is there anyone who may, because when you substitute here, it will produce a positive answer. Magnitude here, any sign, any value of sign which may produce a negative, these magnitudes will help us turn it to positive. N squared will turn it to positive, meaning that we are dividing positive over positive, and then this answer will be positive anytime t. So meaning that being positive, that one we have solved it. So now we are going to see another characteristic. So the first one we have finished and it has passed. The second one, we are supposed to check whether it is decreasing or increasing. That's what we are supposed to check for. So the sequence Bk is not decreasing since sign n is vibrating or is having different values between 0 and 1. Actually, this is magnitude, because remember a sign, those of you who have been doing this for long, you see a sign ranges between, I think you remember what we covered, and what do we call it? Squeeze theorem, yes. We said a sign ever vibrates between -1 less or equal to, this is the sign x, less or equal to +1. But now, because we have taken this magnitude component here, this magnitude, it will help us so much cut off this, and then it will be starting from 0 less or equal to sign magnitude n less or equal to 1. So you see, it is helping us now to forego this negative bit. And therefore, our answer is going to be between 0 and 1. And therefore, this is an expression, but this is an argument. This is what you should write. And therefore, it all just oscillates between 0 and 1. as what? As n goes to infinity. Meaning that when you substitute as many n's as possible, you find between the answers will be lying between 0 and 1, 0 0.0, 0 0.6, 0 0.1, 1, then it goes back like that. You know how a sine behave. That if this is a sine, you find that it will be vibrating like this. Between 0 and 1, so you find that the maximum will be, the lowest will be -1, the maximum will be 1. But because we don't want the negatives, you will find that it will be just showing a part of the curve. And it will be just like as fun as this. It will be just giving you these parts. And in this case, you cannot know whether it is decreasing or increasing, because we said if it is decreasing, should be strictly decreasing. If it is increasing, it should be strictly increasing. So that is the thing. And therefore, we cannot apply, because you see, it has failed. This one has passed. Being positive, it has passed. So it is positive, we cannot argue with it. It is positive. But 2, it has failed. Because they said BK should be positive and decreasing. These 2 should be the first. So even before you take a limit, you should first check for these 2. And therefore, we fail to apply the alternating test. Thus, we fail to apply the alternating test. Hope you have seen. You don't need to draw the diagrams, but you have to, first of all, extract BK, get the cell, extract the sequence as you have seen, extract the sequence BK. Then before you go further, first test and see, is it positive? If yes, you go. Is it decreasing? Strictly decreasing. Is it strictly decreasing? Yes. If yes, go further and look for the limit. The reason why we cannot continue is 1, we have failed to attain the characteristics of the theorem. So we cannot use it. So that's the only thing behind it. Is there any question, please?
Sorry, I can't say the word properly.
What? Here, thus we fail to apply the alternating test. So that is the conclusion there you can put. Because you cannot, therefore you cannot continue. Thus, we cannot apply the alternating test.
Excuse me, sir.
So we cannot. Yes, please.
Even cosine ranges from -1 to 1. Does that mean it would also not apply and it would be divergent?
Sorry, again, the conclusion.
No, here we don't know. Here we don't know, because the test, we have failed to achieve all the characteristics that can enable us test using alternating test. We have failed because 1, this thing is vibrating. It oscillates between 0 and 1 by magnitude. So if you are given such an expression, like someone gives you, let me give you something as fun as this. I was giving it to you, but you chased me. You remember the other one I was giving you, it was -1 to power n, then over maybe n to power a half. If this is a whatever. Now you see this guy, I was to just apply AK.
The conclusion, number 4.
I've said number 4 that we cannot apply the alternating test. It is here. We cannot apply the alternating test. Reason being, it vibrates, a sign vibrates, so it doesn't decrease, no, increase. Okay, let's leave those things. You see here, look here, please. If it is like this, over this is n to power half, then I was to pick my b, but this one I had to rewrite it like this. This is n plus 1 minus 1. Then over n to power a half. And this one I never wanted to calculate because I was to give you everything. So you have to research. So this is negative n plus 1, then times negative 1 to power negative 1 over n to power a half. Can you see that this is the same as writing negative 1 to power n plus 1 times negative 1 over n to power a half? So from here, if this is the number 5, from here, you would have picked, you would have said pick bk, which is the same as 1 negative 1 over n to power a half. Now, let's try to look at the characteristics. 1, bk is negative as n goes to infinity. So we cannot apply the alternating test. Because the characteristics we have failed, it has failed to continue. This is the thing. Someone here may ask you that use alternating test and give a reason why it cannot work. Someone can say, why this one here we cannot use alternating test to test for divergence. Why? Because here, the moment you reach here, there is already a negative which has come. So every answer is going to be negative. So that is enough to chase your way. So you should be knowing at what level, what are the characteristics. So that is the thing you should be knowing. Please, you can write that number or that question. So I'm suggesting we